Hello again. So today we're going to do area of regular polygons. So again, reminder, regular polygon means that all of the side lengths are congruent and all of the angles are congruent. So the center of a regular polygon is right here. But officially the definition says the center of a regular polygon is the center of what's called the circumscribed circle. And yes, that is really what it's called. So I will draw one down here on this regular hexagon. So circumscribed means it's going on the outside of the polygon. That's pretty good actually. Okay, so radius, next thing. The radius of a regular polygon is the distance from the center to a vertex. So from the center of the polygon to a vertex. So vertex meaning the corner. Okay, so we could just draw one of those in there. That is a radius. So I'll put an R on it. Central angle. So that is the angle formed by, and we've done central angles in the circle chapter, but angle formed by two consecutive radii. Okay, so if I drew another radius in there, this would be my central angle. Okay, to find the angle measure, so find a central angle. This is asking actually for the measure. So as you can imagine, if we drew all of those radii in there, we would end up with 6 central angles, and they should all be congruent to each other. So all you do is you take 360 degrees all the way around the shape, and you divide by the number of sides. And that should give you your angle measure, central angle measure in particular. Okay, next, this word is brand new, I'm sure, to everybody. Apothem, or apothem, some people say. I always say apothem. But the apothem of a regular polygon is what gets you that perpendicular that you need whenever you're doing area. Okay, so the apothem is the perpendicular distance from the center to a side. Okay, so in this case, you can draw that in any direction you'd like to, but I'll just draw it this way. So that makes a perpendicular with the side, and that is an apothem. So the radius goes to a vertex, the apothem is perpendicular with the side. Okay, with that perpendicular, we could pretty easily prove it goes to the midpoint of the side as well. But the perpendicular is the important part for area. Okay, identify the center. We're just going to go through these really quickly. So there's no letter on here, so maybe I'll just put one. Identify the center, and if you put an A there, it's A. Okay, you're now going to draw all of the radii. So finish drawing all of the radii in the picture. And as you can see, that splits the shape into, in this particular case, 6 isosceles triangles, because as we all know, the radii are all congruent. Okay, find each central angle. So again, since this is a regular hexagon, you would divide by 6. So each of those would be 60 degrees. So the interesting part about a regular hexagon, since the central angle is 60 and it's isosceles, the isosceles triangles here are actually equilateral, and that's only for a hexagon. But that's just an interesting fact that'll come in handy later. So draw an apothem to EJ. So take a second and draw an apothem to EJ. So segment EJ. So we're going to draw ourselves another apothem here. And that would be A. So obviously you're going to have 6 apothems if you drew them all in there. But this particular one would go to segment EJ. Okay, so there's your vocabulary so far. Now we're going to talk about how to find the area of that polygon. So there are 2 different ways to go. One way is to separate it into those triangles. So to find the area, you basically would have the area of one of those triangles, and I'll put that in parentheses. So that's going to be 1/2. The base is the side length, and the height is the apothem. So again, looking at this picture, this triangle here, maybe I'll highlight it. This triangle here has a height, perpendicular height of A, and then the side length, we would just call that S, and you could do that all the way around. But side length is S, and that's the entire side length. The perpendicular height is A. So obviously the area of that triangle is 1/2 base times perpendicular height. Now, there are 6 of them in the hexagon, but there are however many side lengths there are, that is how many triangles. So you just multiply by n. So you'd find the area of one triangle, multiply by how many triangles there are. So A obviously is the apothem, S is the side length, N is the number of sides. And that corresponds with the number of triangles. Okay, now, but because the perimeter is just equal to the number of sides times the side length, so n times the side, so that number of sides times the side length is equal to the perimeter, you can actually combine this into one big formula, and this is the one we generally use. So we still have the 1/2, and we're still going to have the A, and now we're going to combine the S and the N to be the perimeter. Okay, so this is a combination of this formula. So 1/2 apothem times perimeter is generally the formula we use for regular polygons. So 1/2 AP is what you hear us say all the time. Okay, but just to show you how this works again, we're going to find the area of this particular guy in the 2 different methods. So the first method is just splitting it up into the triangles, multiplying by how many triangles are. The second is using our condensed formula. Now, the next thing to talk about is these are not exact values in the regular polygons. So you actually get irrational numbers, so numbers that go on forever, such as √2 or √3. But for right now, we're just going to estimate all of these areas using estimated lengths. So those of you that love decimals, you're going to be super happy with this particular section right now. And then next chapter, we'll do the exact values, and then you're not going to be as happy. But for right now, we're just going to use decimal values that are estimates. So separating this into triangles, I am going to give you a minute to try and do that on your own. So pause and try to do that. Find the area. Okay, welcome back. So in this particular case, I'm just going to find the area of one of these isosceles triangles. So I have a 10 here. It's a regular octagon, so I would do 1/2 base length times perpendicular height. And I should do a squiggle equals. So that's an estimate. Again, all of these decimal values are actually estimates. So What that gets me is going to be 5 times 12.1. You obviously can use a calculator if you need to. Just going to double check. But 5 times 12.1. So yeah, 60.5. And that's in inches. You should always have your units on your answers. So that is one triangle. Now, obviously, for an octagon, you're going to have 8 of those triangles. So I do 60.5 times the 8, 60.5 times 8, and you get 484 inches squared. So that would be my final answer. Okay, if I just use the formula, so I'll give you a minute to do that. Pause and use the formula. So you're going to do 1/2 apothem, so the apothem is 12.1, times the perimeter. So the perimeter in this case is 10 times 8, right? So that's going to be 80. And then obviously when you throw that in the calculator, you will get the exact same answer. Okay, on the back. So here you have to look at what you're given and try to figure out what you have. It doesn't say that oh, that does say good. These are regular. Also, these should have right angles. But I'm going to give you a second to try 1, 2, and 3. So pause and try those. Okay, welcome back. So a couple of things. You have a capital A. Notice this is units. So that means this is the area. If you just look at the units, you should know that. But I'm going to use 1/2 or A equals 1/2 AP, right? So I'm going to set up 43.3 and then 1/2. I don't know the apothem, but the perimeter is going to be 30 all the way around the triangle. Okay, 1/2 times 30 is 15. So 15A, and then you divide by the 15. And you should get, so 2.89. And this is a linear measurement, so just be centimeters. Okay, the other thing, I did 2 decimal places here because I was given 2 decimal places in the original problem. Generally, you do want to just copy or mimic what they give you in the problem as far as decimal places. So there's that. Okay, next, perimeter is given to me. So again, 1/2 AP. So I'm finding the area. It's 1/2. The apothem here is 10. Perimeter is just given to me. So this one is fairly easy. You just throw that all into a calculator. Okay, and you should get 331.35. And again, area is squared units. Last one, we have a hexagon, so we know n equals 6. I would just write that right away. The area is given to you again, so I'm doing 1/2 AP. Okay, so area is 165.6. 1/2, the apothem is given to me as 6.9. Perimeter, well, this time I don't have the perimeter. I have the number of sides. So I have side length times the number of sides is the perimeter. So that's how I'm going to figure out the S. Okay, so you can multiply all these together and then divide over, but your S should be roughly 8 centimeters. So if you're given, again, 1 decimal place, then 8.0 would be good. Okay, lastly, we don't have time to go through these. So we would be happy to go through factoring problems. You might want to just try them on your own, and then we can go through them in class if you need to. All right, good job. We'll see you next time.